Hello guys, so let's start this second part video. In this we mostly focus on the numerical part. This is going to help you how to solve the numerical, and we'll try to cover the remaining portion of the theory like entropy, gives free energy and all. Let's start with the equilibrium constant, the relative concentration of the product and the reactants at equilibrium is constant. The equilibrium constant, which is represented by K for a general chemical reaction. Let's see, this is a general reaction. So how we find the equilibrium constant? It is nothing but the product upon reactant. This stoichiometric coefficient, whatever the coefficients are there, will comes raised to the power. Like if C is there, capital C is the concentration and a small c is its coefficients, so it will come to the raised to the power. On the same way, here D is there and the one more product which is capital D raised to power D, while divided by the reactant. Okay, let's see now. Next slide. Equilibrium constant K a reachable. Well, a reaction is favored when K must be greater than 1. K has no unit, it's a dimensionless. Concentration of solute should be expressed as mole per liter, capital M. The concentration of gas should be expressed in bar. Express gas as P atmospheric pressure instead of concentration, like 1 bar is equal to 10 to the power 5 Pascal. The concentration of pure solid, pure liquid and the solvents are omitted are unity. Standard states is the pure liquid or solid. Manipulating the equilibrium constant, consider the following reaction. Like HA will give us H plus A minus. So the constant will give you K is equal to concentration of H into A minus upon the reactant. Reversing the reaction result in reciprocal of the equilibrium reaction. So we can state that K dash is nothing but equal to 1 upon K1. Let's see one more. If two reactions are added, then the new K is the product of the two individual K. Here you can see HA is there. HA will give us H plus A minus, or reversing it will give you. So let's see the other value, like other equation, two equation H plus A will give us CH plus. If we are going to add this, so the resultant constant will give us K1 into K2. So you can see the K1 dash with the help of product by reactant, K2 dash, K3 is nothing but the multiplication of K1 and K2. Given the reaction R, equilibrium constant, let's say Kw is equal to 1 into 10 to the power minus 14 for water. For ammonia it is 1.8 into 10 to the power minus 5. Find the equilibrium constant for the reaction. So in this equation we just need to add it by, we just keep this H2 is equal to H plus OH minus, but in this case NH3H2O, first of all we reverse it. For reversing, K2 will become 1 upon whatever the value of NH3, KNH3, so we just reverse it, and finally addition will just multiplication of KW and 1 upon KNH3. So this how the question will be there. We need to solve the answer. Let's see the equilibrium and thermodynamic. Equilibrium constant derived from thermodynamic of a chemical reaction, deal with the relation of conversion between heat and the other form of energy. Let's talk about the enthalpy. Enthalpy, which is represented by delta H, is the heat observed or released when the reaction takes place under the constant applied pressure. delta H is equal to product minus reactant. Standard enthalpy change, which is represented by delta H. All reactant and all products are in their standard states. Delta H is negative, it means heat is released, and it is also called isothermic reaction. If delta H is positive, then it means heat is evolved or absorbed. It means it's an endothermic reaction. Okay, well, we have covered with this. Let's see the next slide now. Entropy. Well, the entropy measure of substance of disorder, like just measure the disorderness of the substance. Greater the disorder, greater the enthalpy. Relative disorder is maximum in gases, then in the liquid, and then in the solid. Entropy is represented by capital S. Change in entropy is equal to product minus reactant. If entropy is positive, so product more disorder. If negative, then product less disorder. Let's check the next slide. Entropy. Increase in temperature result in increase in entropy. Increase occur for all products and reactants. Primary concentration of with del S, which is only weakly temperature dependent. Generally treat del S and del H are temperature independent. Next topic is free energy. System at constant temperature and pressure have a tendency towards lower enthalpy and higher enthalpy. Chemical reaction is favored if delta H is negative, heat is given off, and delta S is positive, more disorder. Chemical reaction is not favored if delta H is positive and delta S is negative. Gives free energy delta G. Determine if a reaction is favored or not when the delta H and delta S are positive or negative. So a reaction is favored if delta H is negative. Guys, so we'll have the formula delta G is equal to delta H minus T del S. So these are the very important point of view as a objective point of view, like when chemical reaction is favored, when delta H is negative, heat given off, delta S is positive, more disorder. So you have to remember. Okay guys, this must be asked in, maybe asking like Cbse board exam or any other board exam, maybe in this the JEE exam, the Neet exam, NET. Okay, just remember this objective. Let's equilibrium and thermodynamic free energy example is the following reactions: HCl, H plus, Cl minus. Enthalpy is given, which is minus 74.85 into 10 to the power 3. Change in entropy is there, minus 130.4. So let's find the delta G. We'll have the formula H minus T del S. On subtraction, we got delta G as a negative. It means reaction favored. Favorable influence the enthalpy is greater than the unfavorable influence of entropy. Now next is free energy and equilibrium. Relative equilibrium constant to the energetic delta H and delta S of a reaction. Equilibrium constant depends on delta G. With the help of this relation, K is equal to e raised to power minus delta G upon RT. R equal to gas constant, which is equal to 8.314. The unit will be joule per Kelvin mole. Temperature will be in Kelvin. The more negative delta G, larger equilibrium constant. For example, HCl is equal to H plus Cl minus. So delta G will have like consider minus 35.97. So with the help of this relation, K is equal to e raised to power minus delta G upon RT. If delta is negative, so e raised to power minus will become positive, and K will have the very larger value. HCl is very soluble in water and nearly completely ionized. If delta is negative, for k is equal to 1, the reaction is spontaneous. Reaction occurs by just combining the reactants. If delta is positive and if k is negative, the reaction is non-spontaneous. Reaction requires external energy to process the proceed. Let's see with the help of this figure. Gas flow towards the vacuum, spontaneous. A vacuum does not naturally form, non-spontaneous. So these are the objective point of view. Ask question, delta G is negative or k is greater than 1, the reaction is spontaneous. So they ask you what is the suitable condition for a spontaneous process. Okay, so these are the conditions. Now let's talk about the Le-Chatelier's principle. What happens when a system at equilibrium is perturbed? Charge concentration, temperature, pressure, or added other chemicals. Here is the reactants and product. When k is equal to 1, it is in equilibrium. When reactants, additional reactant, okay, so equilibrium will vary temporarily. Equilibrium is re-established. Reaction accommodate the change in product and reactant, temperature, pressure, etc. Rate of forward and reverse reaction, re-equilibrium itself. You can see with the help of this graph, forward rate reaction, reverse rate reaction, addition of reactant is here, is some amount of addition, reverse reactions rate starts to catch up. It will try to catch up somehow if you increase the reactant in the reactant side. Next is what happens when a system at equilibrium is perturbed. The direction in which the system proceeds back to equilibrium is such that the change is partially offset. Consider the reaction CO plus 2H2 will give us CS3OH. Well, at equilibrium, here is the condition, CO plus 2H2, that is equal to the product CS3OH. Adding excess CO, it means the reactant will return to equilibrium. Some, not all CO and H2 are converted to CS3OH. If all added CO was converted to CS3OH, then the reaction would be unbalanced by amount of product. For example, consider the reaction which is given here, and we'll find product upon reactants. So we'll get this value at one equilibrium state. This is the value, while other this. What happens when Cr2O7 increase from 0.1 to 0.2? According to this principle, reaction should go back to the left to offset this dichromate on right. Use reaction quotient Q, some form of equilibrium equation, but not at equilibrium. So while putting the value, we'll get 2 into 10 to the power 11, right? So which is greater than K. We'll see if since Q is greater than K, the reaction must go to the left to decrease numerator and numerator increases denominator. Continue until Q is equal to K. If the reaction is at equilibrium and product are added or reactant removed, the reaction goes to left. Okay, let's see with the reaction. So BrO3 minus 2R 2Cr 3 plus 4H2O. Okay, so Br minus Cr2O7 plus H plus product will increase, so it will goes towards the reactant. If the reaction at equilibrium and reactants are added or product removed, the reaction goes to right. So this is a basic nature. So whatever the increases, it will go towards the reverse side. If reactant will be increases, it goes towards the product, and product will be increases, it will goes towards the reactant. Guys, if you have any doubt, then just pause the video, just once again repeat it, you'll get the better idea. Even if some of the time I'm unable to understand the topics in my time when I was in class 11th or 12th, I used to do the same thing. I just used to repeat the topics. Okay. Effect of temperature on equilibrium. Well, combine gives free energy and equilibrium equation. Combining will give us K directly proportional to e raised to power minus h RT. So well guys, for this part of the video we'll stop here. For the last part of this video we'll check in the next video. For this, kindly subscribe the video so you'll get the notification, and we'll make a last video on this for the numerical as well. Till then, thanks for watching. Keep watching the video, keep gaining the knowledge. Best of luck.